Radio. Short and far from the mic, bring your radio to life. Tune in weekly, it's a Ham-filled ride. We got topics, get to tell the heart of five. It's the CQ calling, joining everyone. From Earth to the world, you know how it goes. The frequency is set, let's start the show. It's your European Ham Radio Show. Come on, let's go.
And I forgot to change the intro back to the regular one, but if you don't like it, make your own. And we got a special guest right beneath me here, Mark from Halbert Electronics and the Ham Radio Workbench. And Mark, you're live at Pacificon right now, aren't you?
Thank you very much for calling me, Martin. This is Mark Smith reporting live from Pacificon in California. I realized that my camera is zoomed in really far, so you didn't see the voice modulation technique. I'm here live at Pacificon in San Ramon, California. I was here vending all weekend. You can see my Halibut Electronics booth sign behind me. I'm having a great time here. Thank you very much for having me on the show.
Awesome. That's one of the shows I'd really like to go to at some point. But the list of shows I want to go to and where I actually can afford to go, those are two completely different things. Anyway, we're going to go to the Ham Radio moment of the week. First of all, Sean is out sick today, but since we're so many regulars here on the European Ham Radio Show, we're still a lot of people. But Kjetil, what was your Ham Radio moment of the week?
I've done one activation this week, turned on the radio once, so that's basically it. I had a really nice QSO today with a scout doing jamboree on the air from Gilwell Park. So if you're a scout, you probably know where Gilwell is. It's like the main camp, or it's home for scouts. And that was really nice. I think 11-year-old kids trying radio and having a chat. And I operated him from a park in the middle of a city in Norway. So, yeah, that's it, basically.
Yeah, still a great moment, though. And there might be more scout moments to come since this has been Jamboree on the Air weekend, at least here in Norway. Walt, we talked a little bit about CB radio before the show started. What's your CB radio moment of the week?
I'm glad you asked, because I was going down that road. It was going to be an 11-meter answer. Today, I just got in the door like just before we started here today, and I've spent today with Rob, N1NUG. His channel is 571, pretty popular ham radio / CB radio YouTuber. I have an FM CB. CB was legal now in the USA. 11 meters is on FM 2021. That's when they brought over FM into the CB world. So I'm in Rhode Island. He's in Connecticut. We're a little over an hour away from each other. We installed our new FM radios. I'm mine in my Jeep, him and his in his car, and we drove towards each other, met halfway, and had a QSO going there and coming back. FM 11-meter QSO simplex was a lot of fun, and then we met, had lunch, and off camera, talked about ham radio and YouTube and antennas and all the stuff ham radio operators talk about when they're they see each other. And then and I just got back, so that was a fun day. That really was a blast. It's great to it's always nice when you can meet another YouTuber in person, and that's why Morton, you said you haven't there's places you like to go, man. You got to go to Dayton. You guys got to get over here and go to Dayton with me sometime. I tell you what, Mark, I remember coming to Mark's table this past year in Dayton because I talked with those guys quite a bit. Matter of fact, I was with the president of our Chesapeake Amateur Radio Club. I think he bought some stuff from you, Mark. That was his one thing he told me as we were driving from Virginia to Dayton. He said, I've got to go. He had to come see you. So it is really cool that you see guys like Mark and others that in the industry, in YouTube and podcasting, guys that are just ham radio people. So come on over, guys. You guys got to come to the States. Let's go to Dayton next year.
The flip side of that is I need to make it out to Friedrichshafen one of these years too.
Yeah.
Yeah, that also seems like a really nice show. So, and then there was that one in Newark in Great Britain that I saw some YouTube videos from as well. So, every time I see a video from a Hamfest, I really want to go there. So at least I'm the one in this show with a little bit of impulse control. So
you mean you only have 15 radios where we have 40, right? Is that what you're saying? Like,
yeah, but I do spend my money on radios. I should probably spend them a little bit more on traveling instead. But that sounds like a great day there, Walt. Let's hear about Mark. What's your ham radio moment of the week?
Well, I had a really good homebrew moment on Friday night. So I came here to Pacificon to go hang out with a bunch of hams and whatnot. And I did a small homebrew meetup with a couple of other folks here where we shared our homebrew projects. Mine was a mead that was made with maple syrup and honey, not just honey. And it was aged with an oak spiral inside of it. And I also had a lemongrass ginger mead that I was able to share. And that was really a lot of fun, where we got to share our homebrew projects with other people.
He wins.
Oh,
he wins.
Did you mean the other kind of homebrew?
He wins.
I mean, that was awesome.
Yeah.
Does that homebrew run FT8?
It does, actually, yes. The lemongrass really kind of improves the clarity of the signals up the waterfall.
That sounds good.
Yeah.
Awesome.
No,
Yeah, go ahead, Mark.
I was going to say, my ham radio minute at this point is my voice is getting ready to do In a World voiceover work, because I've been at a convention talking all weekend. So lots of good fun here.
Yep.
So your Darth Vader is getting better every minute, right?
That gig is open. They're looking for somebody. Too soon?
Yeah.
Oh, that's too soon, Walt.
Too soon. Too soon.
Too
Actually,
soon.
the funny part is that he did actually sign over his likeness before he passed away. Disney is allowed to deepfake his voice to continue to use for Darth Vader going forward. He actually legitimately signed that over, and they are paying his estate for that privilege. So how you feel about that, I don't know. But point is, they are not looking for any more Darth Vaders.
I stopped feeling good about Star Wars about 3 movies ago. So
if we're going to take this tangent, you need to go and watch the TV shows. They are phenomenal. They are so good.
I probably should, but I feel that it lost some of its magic. But we're not here to talk about Star Wars, though. Tobias, what's your ham radio moment of the week?
It's still about to happen, because I was so busy this week that I didn't get anything done. But I had the insane idea that I'm doing a live stream myself right after the show. So after we are done here, I'm doing a small kit build, a small function generator kit with the commonly known XR2206 chipset that can do, sine wave, triangle, and I think square wave. And yeah, I will solder it up to have any ham radio moment this week.
But that is ambitious, though. Going on another live stream after we have done our live stream, that is really ambitious. But everyone who watches, please come on over to Tobias's channel after the stream and watch Tobias build stuff. That is always
or fail
always
streaming, because I haven't done a stream in a while. So let's see how that goes.
So, but that is a great moment, and I think this week has been busy for most of us, and that's partly why the stream got posted on Friday instead of Wednesday as usual. Because when I was watching TV with the wife on Friday evening, I got up and said, "I just got to go fix something," and I had to post a stream before I forgot again. So it's been one of those weeks. Bob, how about you? Did you have a busy week?
I seem to having that sort of week continuously at work these days, so I'm having a lot to do. So I'm not too much time to play radio, but there's been some interesting stuff going on. I'd first like to mention that we've probably all heard of it's called the VR N6MTS. It's a new handheld from, is it Vero? It's called the makers of that. radio.
And I still have your Vero, whatever it's called, the mobile one here for you.
Yeah, I'll come and pick that up sometimes when we do a common activation or something. It's no hurry. But the thing is, the new firmware for the VRN76 now has a Bluetooth TNC in it. It's mind-blowing. That means you can do all of the cool stuff that you can do with a D75. You can now do with a $1,500 radio.
I hope it's not $1,500 for the radio.
1,500 the Norwegian, so that's 180 US dollars. Sorry. Currency confusion going on there. So I have to say, as news goes in ham radio, I think that was a pretty cool thing. I haven't had time to play with it, of course, yet, but really looking forward to digging into that. I have the radio, even in red, which adds about 5.5 dBs to the signal. So yeah, looking forward to testing that out. But in real ham radio work, and in honor of our guest today, I've been building the EggNOG I think I spent about an hour putting that thing together. It looks so simple. There's like 5 parts in the box. I actually spent about an hour putting that thing together. And I created a video, and I spent a lot more than an hour cutting that down to a manageable 17 minutes. So if you're a fan of watching paint dry, you can now watch me build the EggNOG.
Hang on a second, that's my channel. You know, don't intrude into my core competency here.
Anyway, do that after Tobias's build live stream after the show. You can go watch that if you want to. Yeah. And I have to say, Mark, fantastic kit. That's just I think the instruction manual for building it is 26 or 28 pages. I didn't need a single one of them. The documentation of the PCBs alone is sufficient to build that thing. It's just fantastic. So I had great fun building it. Sadly, it doesn't make for really entertaining YouTube videos, but great fun building it.
It really doesn't.
No,
yeah, especially when you add whiskey to it. I will ask you when we start talking about EggNOGs. I would like to ask you about what you found time-consuming or difficult, but we'll talk about that later.
Absolutely. Yeah, I think that was my ham radio moment, and as always, I speak too much. So I'll just mention that come Monday, that's tomorrow. I'm going to Germany for a week of summits on the air. So I'm trying to get up towards the Kilo. Now it's not called the Kilo Award; it's called the Mountain Goat Award. So my goal is then to manage that within 3 years of getting licensed. So I need to rack up some points.
And by then you cheat and fly to Germany and do drive up 10 pointers, right?
I think I've done most of the drive-ups in Germany by now, but there are some easy 10-pointers. Yeah, it's not... if you want to do a 10-pointer in Norway, that's basically you need to bring a tent. But down there, last time I was there, I did 5 10-pointers in a day. So that's...
that is helpful.
Yep.
Morten,
awesome.
Before you go and wrap this thing up, I want to say one thing off topic. I've been holding this thought. Mark brought up point the other way. Mark brought up one more off-topic thing. He talked about the television series. Mark, I'm the biggest Mandalorian fan ever. I've never missed an episode of Mando. So you were right. The television side.
Yeah. Ironically, Mando is one of my least favorites. It's fantastic, but the other ones, Andor was great, and then all the cartoons like the Rebels was fantastic, and Bad Batch and all of that is just such great storytelling.
Mando brought us Baby, what's his name?
Baby Yoda.
Baby Yoda.
Yeah. Anyway, all right. I'm sorry to get off topic. I've just been holding that thought the whole time. I was like,
awesome, and that brings it on to me. And first of all, you should have thought that my ham radio moment of the week, and I got to see if I can press the right button here and get this up. And Tim, I know you're in the chat, but Tim says that he doesn't do any unnecessary live streams which chat about nothing for an hour with others who know little. And thank you, Tim. I'm so happy that you're not trying to compete with us. And Tim, just to clarify though, Tim is a friend of the channel, and Tim is a great guy, and he's got a great YouTube channel. But I just feel I had to address. I felt I had to address that for just a little while. So well, I know you can take it, Tim.
let's make it clear, Tim. We know you weren't talking about us. You wouldn't be in the chat if you were. We've had some fun with this in the background. How about that?
Yeah.
Yeah, and we made sure that the guy everybody had on Facebook called Little for a last name, he has no friends anymore.
So let's see here. But that's not my ham radio moment of the week. For being as busy as I am, I've actually managed to do a lot of ham radio things this weekend, but the most important one was during Jamboree on the air yesterday. I'm not a scout. I've never been a scout, but LB4LI. I keep mixing you up, shit, and sorry about that. Joachim asked if I could help him out and show some radio to some scouts. So I took a group of, I think it was 4 scouts and 1 parent out to do Parks on the Air activation. First, I got some short QSOs with the other scouts that stayed in the cabin, and then we did a Parks on the Air activation. And I think I've recruited at least 2 new hams out of that group of 4 or 5 people. So that was fantastic.
Yeah, and if you're gonna do Jota Jamboree on there, that's the way to go. Like, bring the ones that actually want to do it and do something cool, not just sit there and wait for 80 meters. Just do cool stuff.
Yeah, when my first QSO on POTA after they were done talking to each other was the SOARs, and that was just pure magic to those scouts and the parent.
Yeah, that's good.
So hopefully we'll have some new hams. The moment we got a new license class in Norway, which makes it a little bit easier for kids to get licensed. I could have talked about a lot more ham radio. I've been playing a lot with the Flex this weekend, but that's probably a subject for a video that no one's going to watch because people tend not to watch my Flex radio videos. And then I played with the little dude and made some. If you think that's funny, you got to watch my video, though. I got to say, it's a grower and not a shower.
Oh, man. Yeah.
I don't know what Sean was thinking about when he
that
called
escalated
his
quickly.
mask, the little dude. But enough about that. Mark, you're here to talk about EggNOGS, and knowing you well enough, I think you're probably going to mention a couple of your other products as well. But primarily EggNOGS, since Bob over here managed to buy one of your kits. So what is EggNOGS?
So EggNOGS is a kit to help you build an egg beater antenna. Are you familiar with egg beater antennas? Well, somebody in your audience may not be. An egg beater antenna is an omnidirectional antenna with a roughly hemispherical radiation pattern. That is to say, you can see everything at the horizon and straight up, right? It can see the entire sky, which makes it good for listening or talking to satellites. Except for the fact that it has, its advantage is that it can see the entire sky. Its disadvantage is that it can see the entire sky, meaning that it has absolutely no gain. As opposed to a Yagi antenna, you're trying to figure out which button do I get this? A Yagi antenna will always outperform an egg beater antenna, but you have to point it at the satellite as it moves through the sky, which is challenging because, it's constantly moving. The egg beater you can stick up on the side of your roof and permanently mount it there and run a coax down to your shack and not have to worry about pointing this at all. You can see the whole sky at once. So you're kind of trading antenna gain for simplicity of your antenna. So that's what an egg beater antenna is. Technically speaking, it's 2 full wave loops mounted at right angles to each other, and then fed 90 degrees out of phase from each other. Now the hard part with making an egg beater antenna is that phasing loop between these two aerial loops. These antennas are balanced antennas, so your feed line that you're using for that phasing loop should be balanced feed line. These antennas are 100 ohm, so that it should be 100 ohm feed line. And there's a whole bunch of other crap happening down here, so it should be shielded feed line. I have never found a spool of 100 ohm shielded balanced feed line. So that's kind of unobtainium. So making a proper phasing loop between these 2 antennas is a real challenge. Generally, people will hack it either by using unbalanced coax or making a balanced a feed line out of 2 parallel pieces of coax, but then you need to make sure to trim them at exactly the same length. It becomes a challenge. The magic that I found out was that you can design a transmission line into a circuit board, and you can design a balanced transmission line into a circuit board. And then if you put that balanced transmission line on the inner 2 layers of a 4-layer board, and then put copper pores on the outside, you can make a balanced, shielded 100-ohm transmission line on a circuit board. And because it's designed on a circuit board, it is incredibly precise and incredibly recreatable, reproducible. They are consistent every time. So that's what I did. And that's kind of the magic of EggNOGS, is that I did all of the math to figure out how to do the phasing loop on the circuit board, and then designed it with a relatively convenient way of soldering it onto the physical board on the top that does all the mechanical attachments and whatnot. So when you buy a kit, it comes with all of the parts that are in my hand except for the wire. So it comes with the circuit boards, with the phasing board for the band you want to do. It comes with the common mode current choke, this ferrite bead here, the coax that goes through the ferrite, and the feed point connector here, and the zip tie, and also the PVC cap with all of the holes drilled in the correct places for these, and all of the stainless steel hardware. So everything in this hand, except for the wire, comes in the kit. You only have to provide the things that you can get at the local hardware store. This is just 14-gauge Romex wire, like house wiring, and then a 2-inch PVC mast, or for you non-Americans, 50-millimeter PVC.
And speaking about that, I'm just going to interrupt you a little bit here, Bob.
Yeah, please.
Did you figure out a solution for the 2-inch PVC pipe?
I did, but I think Mark's video froze. Are you still with us, Mark?
We got a bad habit of losing.
Your video has frozen to me.
Oh, now you're back.
You guys are back. Let's see whether I come back. Okay.
Yep.
You're back.
Yep, you're
Excellent.
back.
First of all, Mark, have you got a ruler where you set something to measure with? Ooh.
And we're losing Mark again.
Really?
You're back now.
Oh shoot!
Because I measured the inside of that cap, and mine measures 60.1 millimeters.
So, 2-inch PVC is not 2 inches outer diameter.
Right.
Of course.
Of course not.
Well, here we have.
Of course not.
Schedule 40.
All right. Yeah.
Because 87.3 barleycorn probably. No.
being used to European measurements, we would assume that that was an outside diameter, but yeah. What Morten asked is if I found a way to fit that, and that was of course a quick 3D print with an insert to a 40 millimeter outside diameter plastic pipe that I've mounted mine to. So that took about 90 seconds in FreeCAD and a few hours on the 3D printer. And so that was a solved problem.
Can you please send me a link to that STL file if you're willing, so that I can share that with my other non-stupid US measurements customers?
I'll even send you the FreeCAD. It's a parametric design in FreeCAD, so you can make that for any diameter you want. I'll send it to you. So,
awesome, thank you.
Awesome. Yeah, it's very cool. Yep.
You know, here in the States, we not only do we use the crazy imperial measurement, then we take stuff like pipe and call it Schedule 40 and make it bigger than 2 inches. And then we take wood, which we call a 2x4, and make it smaller. It's like 1.5 by 3.5. This is how we are.
The wood at least makes sense. We take a 1/4 inch off all side for surfacing. But once you understand it that way, it's like it makes a heck of a lot more sense. But yeah, it is pretty dumb.
We got a couple of comments and questions here, Mark, since I've already interrupted you. First of all, Chris would like to get sat photos for weather. Can you use the EggNOGS for that?
Yes, in fact, I have a phasing board specifically designed for 137 megahertz. So if you go to the webpage and check out SatNOGS, It comes in 5 different varieties actually. 436, 145 for the 2 ham bands, and then 137 for weather satellites, and then there are a couple of commercial channels at 388 and 401. So I have phasing boards for those as well. Hang on, doesn't need it. Okay, sorry, I'm also trying to do a credit card sale while I'm here, so I'm the only one who can handle the credit cards. So
that is a proper multitasking. I can answer William's question. That's you decide whether it's right hand or left hand by the way you put it together. You can you can show it, of course, Mark, if you have the thing in your hand there.
Yeah, so it's similar to a QFH. Yes, in fact, I call it EggNOGS for egg beater antennas, but really it will work with any quadrature fed antenna. Any antenna that you need to feed 2 different loops or 2 different balanced antennas 90 degrees apart, it'll work with any of those. So like a quadrifiller, a turnstile, an egg beater, anything like that. I call it EggNOGS because I was trying to build an egg beater antenna for SatNOGs, and the pun was just too good.
Yeah.
Was too good to pass up. So on the main board here, I don't know if you guys can see it. It says select polarization up there. And then on the phasing board, you have a right hand circularly polarized and left hand circularly polarized. And which way you insert this phasing board into the main board, it will determine the polarization. So if you put it in this way, it's right hand. If you turn this over and then insert it before you solder it in, it's left hand polarization.
Oh wow, that's cool.
And once again, the documentation, it's quite literally on the PCBs, so you don't even need that big piece of documentation. You just, if you have eyesight, you can put this thing together.
We're all middle-aged men.
You're talking about weather satellites and different frequencies or whatever. I had, coming into this, it's going to be a question I was going to have you. I had this idea of 2 egg beaters sitting on the beach in my Jeep, 1 egg beater for uplink, 1 egg beater or EggNOG for downlink, and sit there and work the ISS if it flew over the Atlantic Ocean. You know, like that is doable.
Yes, absolutely. So especially with the ISS. So I was mentioning how egg beater antennas in general have rubbish for gain, right? So you need to. It doesn't work great on the low power CubeSats. Right. If you have a low noise floor around you and you have an LNA, then you can probably pull those signals out. I live in a suburban area and the noise floor is high enough that even with an LNA, I can't pick out a lot of the really weak satellites. This thing will receive the ISS without an LNA all day. The ISS is putting out enough power that it can hear the ISS no problem. On the transmit side, kind of what I'm comparing it against is if you're out there with an HT 5 watts transmitting into a handheld Yagi antenna. Those handheld Yagi antennas have somewhere between 9 and 12 dB of gain over the egg beater. So I'm going to hand wave and say 10 dB of gain. The antenna gives me 10 dB of gain on 5 watts, I should be able to accomplish the same thing with 0 dB of gain and 50 watts. So my goal is for this thing to be able to handle at least 50 watts of transmit power. I am not yet claiming that it can do that. What I have tested is 18 watts measured at the antenna feed point of a constant FM carrier for 3 minutes. A constant FM carrier for 3 minutes, and everything in here got up to about 60 C, which is warm, but not dangerously warm. Nothing's going to fail at 60 C. The other thing to note is that this was just laying down and sitting on a chair, so it was probably horribly mistuned, which is going to make the temperature of the common mode current choke even worse. So I was measuring it in kind of a worst case scenario. If I measure it in free space on its mast at 50 watts at the antenna with a 50% duty cycle, then I am pretty confident, but I have not yet proven that this will handle that no problem. And that's what my target is. So once I am able to prove that, then I will comfortably say that it can handle 10 dB up on an HT or 50 watts, and which will give you roughly the same transmit signal.
That's awesome. I have that little Q900 radio, and I was thinking that would be a way I can actually use that would be set up 2 egg beaters in a nice cold winter day, sit inside the vehicle and work the satellite from it. It's kind of the idea I'm having right now.
That's pretty
Tobias,
smart.
can you bring up Chris Bricker's? Can you bring up Chris Bricker's question?
Yeah, the field of view. That one?
That is not the one I was looking at, but that one works. What is the field view of this antenna if it's sticking straight up? So the big advantage to the egg beater antenna, not just mine, but egg beaters in general, is that they have a roughly hemispherical radiation pattern. They can see all the way down to the horizon, and they can see straight up, which is kind of what makes them better over the vertical antenna, which has a great view of the horizon, but a deep null pointing straight up. The one that I was looking at was did you say 50 watts? 50 watts is a lot for these sets. It is, but remember, I've got 10 dB less gain on this antenna. So 50 watts into this antenna is going to give you roughly the same signal strength satellite as 5 watts, which is kind of what I'm trying to equate. Did I lose you again?
No, you didn't. You almost lost us, but you didn't lose us again.
Okay.
We copied all.
Okay.
We got a couple of more questions. I hope that's okay for you, Mark.
Yeah, please.
Abe here asked if each band is mono-banded, and you've somewhat addressed this already.
The antennas are inherently monoband because of that phasing loop. The phasing loop is a quarter wavelength at the operating frequency. And so if you try to operate at a different frequency, that phasing loop is no longer 90 degrees, it may be 120 degrees or whatever. It's not going to break your radio, but it will distort your radiation pattern. So instead of being circular in azimuth, where it omnidirectional, instead of being omnidirectional, it will kind of oblong it. So you get a little bit better in one way, but worse in the other direction.
Yep. And then Andy asked if you can use this with a preamp, and I'm sure you're going to address that a little bit later on there, Mark, but...
Thank you for the segue. Yes, so a product that I am working on but have not released yet is called EggNOGS. EggNOGS is a low-noise amplifier, an LNA, that is designed, you'll notice that as an SMA male on that side and an SMA female on that side. It is designed to attach directly to the bottom of your EggNOGS antenna. And so it is as close to the antenna as you can get it. It is powered by bias voltage coming up the coax. And then it has a relay there. So when bias power is coming up the coax, it'll power the LNA, and it will flip the relay so that the LNA is in circuit. Normally open state is with the LNA in circuit. The normally closed state is bypassed. So when you remove bias power, the relay flips over and bypasses the LNA and goes straight into the antenna, so you can transmit too. So it is a transmit-capable LNA. Bias power, it's in receive mode with the LNA in line. Without bias power, it's in transmit mode, bypassing the LNA.
And I'm sure you got a solution as well for the bias power there, Mark.
So let me bring up another product that I'm working on called TEHRS, TEA, because we got to stick with the drink theme. So this is a bias injector. You got You've got the RF to the radio and the RF to the antenna. I may have pointed those incorrectly, but whatever. One to each, and then it does the bias injection inside. You've got DC power in, either an Anderson power pole or a USB-C, and an RCA socket that connects to the PTT signal coming from your radio. So when your radio signals a PTT, this will remove bias power from the coax. But when your radio is not signaling a PTT, it will send bias power up the coax. So this and this together, so the TEHRS and the EggNOGS together, become a transmit-capable low-noise amplifier on receive, if that makes sense.
That makes a lot of sense.
I have a question regarding that. How do I get on the waiting list to buy one?
Go to halibut-electronics.groups.io and you sign up for the mailing list, and that is where I announce new products. So if you want to know about a product when it first comes out, so you can get on and order it immediately, sign up for the halibut-electronics.group.io.
I will do that. And if you need a tester in sort of a Nordic environment, you can just always reach out, and I'll be happy to help.
So I will give a caveat. I'm talking about 50 watts of
For
transmit
Aurora
power.
proofing it or something like that, right?
That's right. That's right. I do not know whether the LNA will handle a full 50 watts. I have not tested that at all. I have not done any math to figure out whether that relay will handle 50 watts. So with the LNA, it may be closer to QRP, 5 to 10 watt power levels. I'll get back to you after I have a chance to test them.
Yeah, but that, I mean, most satellites are one band for uplink and one band for downlink, though. So
correct. Yeah, that's true.
That wouldn't be much of an issue at most times.
See, my intended use case, or at least one of my intended use cases for the 2-meter EggNOG is running a SAT gate for ISS. So that would actually be very useful for that use case. So.
And I understand I understand the 50 watts and the Yagi and the decibel, using the 50 watts, whatever. But isn't that kind of like Italian QRP? You know what I'm saying? That whole idea of like for a satellite, 50 watts is for a satellite. I think still, even with the amount of gain you need, a 10, 15 watt with that with your EggNOGs, it should be more than enough. It seems to me.
Until you're trying to capture the satellite from somebody who's using 40 watts, 50 watts into a handheld Yagi, and they are always going to capture instead of you. So yeah.
Yeah, I understand that. I operate a lot of QRP. I get stepped on all day long, so I know what it would be like. And I'm sure it's much more frustrating working satellites because they're just like thirsting for that contact, especially the ISS or something. You know what I mean? That's a big deal. So yeah.
Do you have to get these things high up from the ground? I'm thinking the antennas, not the satellites.
The satellites need to be high off the ground. Yes, it just needs to have a good view of the sky. It's not like a 3-element beam where you need to get it 30, 40, like 10 or 20 meters in the sky. You don't need to get it that high. As long as it has a reasonable view of the sky and the horizon, then it should be fine.
Yeah,
I think most egg beaters they will work maybe a little bit better if you do a reflector on them, and that is I think ideally about a half a wavelength down from the egg beater.
So interesting story. They are not reflectors. They are ground planes. They actually pull the radiation pattern down toward the horizon. Believe it or not. I was surprised as hell by this as well. So the reason you want to pull your radiation pattern down toward the horizon is because when it's at the horizon, it's a lot further away, right? The R² or D² loss is much worse at the horizon than it is when it's straight up. So you actually want less gain straight up than you want at the horizon, and that we'll call it a ground plane or the reflector, whatever you want to call it. It actually pulls it down instead of pushing it back up again like a reflector would.
I knew this. Case in point with that, Mark. If you look, I'm being a shipbuilder. If you look at any defense, any warship, and you look out on the yard arms, the coming off the mast, you'll see egg beaters on just about any American warship, and probably Royal Navy and others. If you look close and zoom down in them and look at it from a picture, you'll see that a round piece of plate, like around it, metal plate around it, that's creating that exactly what you're talking about. That effect, to bring the signal down. I actually, when I was working in Poland, we had egg beaters at the missile site we were at, and the guy was explaining to me just what you just said. He said it's kind of like it is a ground plane, but it's not. It's just kind of like almost like a director. Not a reflector, a director. It's bringing the signal down and directing it out. I have that explained the same way. But look at the Navy ship. I'm picture. Check it out.
I had no idea. I'm definitely going to go do that. That sounds cool. I do not understand from a physics standpoint what that is doing down there. So From an eggnog perspective, EggNOGS actually doesn't do anything to help you build that, because the physical construction of the egg beater antenna is still up to the builder. The only thing that EggNOGS is really providing is that feed point and the phasing part of the antenna. The loops, you are responsible for building yourself, the mast, the attachment of all of that fun stuff. And then if you want a ground plane or reflector or director, whatever the heck it's called, if you want that thing underneath the antenna, EggNOGS doesn't really do anything to help you with that. It doesn't require it, nor does it eliminate it, right? It's totally up to you on what to do with that.
Have you considered, I love the idea of phasing, have you considered or toyed with the idea of putting together something similar to phase HF antennas on the ground, like verticals or something like that?
I think that'd be hard to do on a printed circuit board. That'd be hard to do, I think.
Yeah, the wavelengths are going to be a hell of a lot longer.
Oh yeah, absolutely. But I've played around with co-phasing and that type of thing. You know, especially like right now with 10-meter band, you can use smaller antennas. I was wondering the idea of phasing two antennas together, in phase, out of phase, whatever, to do that. And it seems like the circuitry would be somewhat similar.
Well, so the switching of phasing loops, I mean, that's just relay switching, right? But the problem that I'm trying to solve is making a phasing loop that is 100 ohm balanced transmission line. If you're talking about a vertical, you just need standard 50 ohm coax for that, for the actual phasing line itself. So really what you're looking for there is a precisely cut to length of coax, and then the ability to switch it in and out, right? Switch it in so that your feed line has to go through it, or bypass it so your feed line does not go through it.
Right.
I don't really see how, I mean, like, unless we were trying, let's see what we do. So 10 meters, a quarter wavelength on 10 meters, if you're trying to do a 90-degree phase shift, would be 2.5 meters. But the velocity factor on a PC board is about 0.45. So you're actually looking at closer to a little bit over 1 meter. So you would have to have a trace on the PC board that's a full meter long. Like a one foot square. I mean, you probably could do that.
I get it. Because you're at higher frequencies, you're bringing that down onto the circuit board, and when you get to HF, it's impossible. You might as well just do it the right way and do it with
coax.
Yeah.
Especially since in that case you can do it with coax, right? Because the phasing line you're looking for is 50 ohm unbalanced. Great. We all have 50 ohm unbalanced feed line. It was the 100 ohm balanced feed line that we had a hard time with on the egg beaters.
A cool thing when you do it with coax as well, you don't need a relay, so any other fancy stuff. You can just have different lengths of coax that you switch in and out to do the different sorts of phasing. So that's anyone. If you can shrink on a connector, a coax connector on a coax, anyone can do that with a simple bit of mouth.
I agree with what Tim just said too. I feel smarter already. We're 45.
Yeah, I mean, our slogan is that there's nothing magical about it, but this is like listening to the Ham Radio Workbench. There's a lot of magic going on that I don't understand here, but it seems to be working.
Yeah, we'll get there.
The use for these ones, is that is it primarily satellite comms, or do people use it for like point to point on the ground as well?
So you certainly can use it for terrestrial comms, but it'll be lower gain than a simple vertical antenna.
Okay.
Because the vertical antenna is only radiating at the horizon, right? Whereas the egg beater is radiating at the horizon and straight up. And so, at the horizon is a little bit less so that it can go up as well. And it's also a much more complex antenna than a vertical. So if all you're interested in is terrestrial, you're better off with a vertical. If you want one antenna to be able to do terrestrial and satellites, yes, an eggnog will be great at that. If you've already got the radio hooked up to your EggNOGS and you want to hit the local repeater for a bit, totally fine.
I can't remember, you said in the manual or the assembly instructions, but isn't it primarily horizontally polarized at the horizon? Is that correct?
Correct. It is horizontally polarized at the horizon, and it becomes circularly polarized as you go up.
So basically, it wouldn't be brilliant for local repeaters, but if you want, let's say you want to do FT8 on 2 meters, for example, that would be a rather nice antenna. If you're not allowed to, or if you don't have the money to put up a proper Yagi, then you will actually get horizontally polarized 2 meter antenna out of this that you can use for digital modes as well.
You could do that, but you still, for 2 meter digimodes and sideband, you need a lot of gain in your antenna, though, Bob.
I've done it on a vertical and worked as far as Åland. So when the conditions are right, you can use any piece of wet noodle.
Yep.
It's all dependent on propagation and conditions right now, right?
Yeah.
What you lose in gain from a Yagi, but what you lose in gain from a Yagi, you win in simplicity. Because when I got my Yagi pointed that direction, but I'm getting called from a station in that direction, I'm not going to hear them anymore, right?
No.
Yeah, so.
And I think we said it many times, the best antenna is the one you actually have. So.
Yes.
Exactly. But I'm really looking forward to hearing your thoughts on this after having used it for a while, Bob. Because
me too.
Yeah, sadly, I'm going to Germany for a week, so I won't have time this week. But hopefully next week.
But what I'm thinking here, Mark, is that the EggNOGS solves a problem I didn't even know that I had.
We are so good at that on the Ham Radio Workbench. I had no idea I wanted that very expensive toy.
Exactly, yeah.
Because I feel I need to do satellites from my shack right now.
But you need 2 EggNOGs now. You need 2.
Yeah, I need 2 EggNOGs now.
Yeah. That's exactly what I'm putting up on my shack. I want several EggNOGs. I want 3 on SatNOGs, so a UHF, VHF, and a WeatherSat, and then I want 2 on my Flex through a transverter, so that I can actually operate satellites, and including the linears at that point, right? So I'm just going to put a whole crap ton of antennas up on my shop.
Yeah, and that brings us on to transverters. So this is going to get expensive really fast.
Oh my gosh!
You don't need transverters if you have a radio that can handle it already. So
so the other option is to get a 9700, which is the other thing I'm really tempted by.
But you're not a Flex user yet, Bob, are you?
Are you going to start with me now?
Because if you were a Flex user, you'd appreciate the ability of doing this through a transverter instead of using a separate radio.
I actually have a Sun SDR DX2, I think it's called, which does 2 meters as well. So and that's not entirely unlike a Flex, I think.
This antenna, Mark, do you cover it, or do you run the wires naked up there, exposed to the weather?
So the wires are exposed to the weather. The hardware that comes with it has a rubber washer grommet gasket thingy that seals off the hole right there at the base. Now, I live in California. I live in coastal California. Weather, to me, is very heavily quoted. I do not have proper weather, so I don't know how good of a job that's going to do at weather sealing. I need people up in the Nordic part of the world to get one of these and deploy it and tell me how it does in proper winter. So I am very interested in hearing your experiences, Bob. But I did at least try to put a sealing gasket there right at the transition between the PVC cap and the stuff on the outside. You do not have to cover this.
Maybe we need some 3D printed cone thingy, otherwise the snow will build up there next to the 4 screws, right?
Yeah. Would it be affected by that at all? Like if you had, for example, a bucket over it to cover it?
I mean, no more than it would have impact anything else. I mean, you'll get a little bit of loss from it, but...
You also, this might be in my experience, when I put an already tuned antenna inside something plastic, then that it makes an effect on the velocity factor of the antenna as a whole. So you probably have to retune it if you put it inside a plastic container.
Yeah.
So, but that thing looks mighty solid. I don't foresee that being a problem being outside. And as you also said in the instructions, the thing with the waterproofing, make it difficult for water to get in and easy to get back out. So on that pipe, I'm not going to have anything at the bottom. So if a drop of water gets in there, it's just going to find its way through and fall out the bottom. I'm not worried about that.
Yeah, but I'm probably not the person to talk to about weatherproofing antennas out there because it's cheating where I live. Like winter field day is absolutely cheating where I live.
Quick question, Mark, since we've talked so much about satellites, and you probably know where this is leading, but is there any chance of seeing SOAR coming back on the drawing board?
All right, so oh shoot, oh, there it is. It's already out on the table. So I always bring my SOAR prototype unit with me to conferences for people who ask the question you just asked, because I get about 10 questions every single time I do one of these conferences. This is what SOAR looked like. So for those who don't know, SOAR was the first product that I designed that never went to market. It's called Satellite Optimized Amateur Radio. It's basically an appliance for operating FM satellites. So the idea is that it is a full duplex capable VHF and UHF radio, and it has a GPS built in, so it knows where it is and when it is, and then it's got SD storage inside with a USB port here that you can use to copy amateurs.txt or the TLE data, the information about where the satellites are. It describes all the satellite orbits. So if you know where you are and when it is and where the satellites are, you can calculate the relative azimuth and elevation and display it on the screen. So this will have an azimuth and elevation display showing you where the satellite is. And you could also calculate relative velocities. How fast is the satellite moving towards you or away from you, which allows you to calculate the Doppler shift that you need to apply to the frequency. So this radio would automate all of the hard parts of doing a satellite, is the Doppler shift and the azimuth and elevation. It would show you where all of that stuff is. And then the other thing it does is that it would record the audio of the pass. It would record your microphone audio, the uplink, and the downlink, the receive audio, on separate channels in a WAV file, kind of left and right channels in an audio WAV file. All of that would be stored on the SD card. So it was a great little product. I was super excited about it, and I got to the point where I was ready to release it to the public. I even bought all the hardware for my first production run, and then I verified, unfortunately, something that I assumed I was going to be able to fix. This is an SA868. It is very similar to the DRA818 or the SA818, the little HT on a module, right? It is analog audio and serial port in one side, 1 watt, or this one is a 2 watt version, RF out the other side, right? It is an HT on a module. And I've got a VHF module down here and a UHF module up here. Both of them have to transmit into a bandpass filter to be able to do full duplex, right? You can't have one transmitting and desensitizing the receiver of the other one. And that goes both directions. So they both need to be very strongly filtered. And I designed filters that would do that. And the VHF module transmitting into that filter works great, right? It transmits, it receives, it has okay sensitivity, not fantastic, but it was okay. The UHF module, as soon as it tried to transmit into a reactive load, like the filter down here, it broke. I usually use another term, but I don't know whether we're a family show here, so I'm not going to use that term here, about making a big mess in the bed. But its output power just wildly oscillated all over the place. It was never predictable. It was broken. It did not work. It goes into an antenna without a filter, works fine. Send it into a resistive load, like a dummy load, works fine. As soon as you try and put that filter on there, it did not work. And I spent a lot of time working on it with my friend Marcel, N6MTS, who's actually here working the booth for me right now. He's going to come around and say hi. There's Marcel.
Hi.
Marcel did a lot of engineering on this to try and help me figure it out. I paid another RF engineer who is a listener to the show a couple grand to dig into this and try and figure out what was going on, and he wasn't able to figure it out. And the real kicker was that I found another product on the internet that used that same module for their product. And when you bought it in the VHF version, it came with a bandpass or a low-pass filter on it to clean up the harmonics that it would transmit, because it's basically a bow thing on a module, right? It's going to be dirty. And when you bought the VHF version, it came with that low-pass filter to clean that up. When you bought the UHF version, they bypassed the filter. Like, the outline is still there on the board. They just had a wire that connected the input to the output of the filter with no components on there. And when I saw that, I'm like, oh, for Pete's sake. Like, they ran into the same problem that I did, and they weren't able to solve it. They had an option of just bypassing the filter and saying, you're responsible for dealing with that yourself because you're a ham. I can't do that on this, because it will be non-functional as a full duplex radio if you don't have that bandpass filter in there. So once I discovered all of that, this became a non-feasible product. The next step for me to do is to design my own version of that module. And where I was at the time, this was about 2 years ago, I think, I did not have the skills or the experience to be able to do that. The reason I wanted to do this project is because all of the RF parts were solved for me, and I could concentrate on the digital and the audio of all of this and let the RF be handled by these modules. In those 2 years since then, I have done more RF engineering, and I am more confident that I can successfully design that module. So I'm going to finish up all of the EggNOGS stuff, and then I think I'm actually going to spend some time with designing a open source module that is functionally similar to the SA818 or the DRA818 or 868. It's a whole family of things that are very similar. That is functionally very similar to that, where you've got a serial port to control it, maybe a couple of GPIO pins for like PTT and whatnot, and analog audio input, and then 5 watts of RF power out the other side. But I will be using a Mitsubishi power amplifier module and let them handle the high power RF stuff. They make these little tiny modules that is 50 ohm RF in, 50 ohm RF out. You give it like 20 milliwatts in and it gives you 8 watts out with DC power in there, and just a super simple module that handles all of that for you. I'm going to use that as the PA. And then I haven't exactly figured out what I'm going to use to drive that PA yet. So anyway, point is that I'm going to be designing that module and releasing it as an open source module, and that will hopefully get a bunch of people using it, and we can tune that module to be the best that we can make it. And then once I'm happy with that module being a very good RF platform, then I'm going to take that open source module and put 2 of them in SOAR, one for VHF and one for UHF, and get back to designing this radio with all of the functionality that SOAR has using those open source modules.
Awesome.
Fly again. That's fun there. SOAR and flying. But yeah, that's awesome.
Yeah, and I see that Chris says that you guys need to talk. He's a PCB designer and would like to talk more about you. So
So electronics@halibut.com. Go to the contact us page and send me a contact there, or mark@halibut.com is the easiest way. My email address is mark@halibut.com. Let's chat.
Awesome. And I see that we're getting close to the hour mark, and Tobias needs to get ready for another live stream here. But thank you so much for being on, Mark.
Don't let me stop you. I start my stream whenever we are finished here. No need to rush.
I have a request before we let Mark go. I was hoping to talk about the open headset interconnect standard as well. Can you please come back another time?
Absolutely. I've got time. If you guys want to keep going, I've got time. But if you have a hard stop, then we can stop.
Not really. I don't know, Tobias. You're the guy that has a scheduled live stream coming up.
Just go on. I still have 15 minutes to go.
So go ahead, Mark.
Okay. Did you have a specific question, Bob, or just in general, what is it?
Absolutely in general, what is it? And
okay.
Yeah, but I think this I was hoping we could do a whole show on this because I think it's important work. And
okay, but let me give you the quick elevator. Let me give you a quick elevator pitch now, just to whet your appetite, and then we'll come back and do another show. Absolutely. So the Open Headset Interconnect Standard is a open standard, hence the name, that I am advocating for in the community and the industry to standardize the interface between the radio and the user. Right now, if you go out and buy a Heil headset or a Radio Sport headset or a cheap PC headset from Amazon, you can't take those headsets and plug them straight into any old radio. You need to get an adapter that goes from that headset to that radio. You buy another radio, you need another adapter. You buy another headset, you need 2 new adapters, right? And you end up with this full mesh of adapters from every possible headset to every possible radio. In your home shack, that's probably not that big of a deal. But if you go to a multi-user environment like an EOC or a club station or a field day event, I've got my headset already. I've got this wonderful Heil, and it's already got my ear goobers in it. I don't want to wear your headset that has your ear goobers in it. So I want to be able to come in with my own ear goobers and plug them into any radio in this environment. So we take that one adapter between the headset and the radio, and we split it into 2 halves. I've got one adapter on the headset that stays with that headset, and it's only unique to that headset, regardless of what radio it plugs into. And then on the other side, you have an adapter for that radio that is unique to that radio, regardless of what headset plugs into it. And you have a standard interface in the middle. So once all of your headsets are adapted to the standard and all your radios are adapted to the standard, any headset can plug into any radio.
That sounds like such a sensible idea, and it's a huge shame that the ham radio marketplace doesn't work like that already. But
it's like everybody is using power poles these days for their power delivery. Yeah, so this is what you're trying to do with headset and microphone. Yeah, have a standardized connector, and you just show up and plug it in, and if you're successful, sooner or later the manufacturers put it into their devices, and you won't have the adapter to the common interface on the radio side anymore.
I look forward to the day when I can no longer sell adapters. I look forward to the day when I can no longer sell adapters because all the radio manufacturers adopted it natively.
And as you said, Mark, you also look forward to be able to create things that you can plug into this one thing.
I was going to save that for the next time.
Yeah. We definitely need to have you on about this at a later date, Mark. So I'll send you an email.
Quickly,
we'll find a date. And if you want to see Mark talk about the OHS Open Headset Interconnect Standard, make sure you're subscribed to the channel. And
this channel,
and also listen to the Ham Radio Workbench, of course. Walt, you had a question?
No, I was just saying I like the idea of keeping your ear goobers to yourself. That's a great.
Yeah. So ear goobers is actually in the glossary of the document. It's not actually referenced in the document anywhere, but I did put it in the glossary because I use the term. Anyway, Tim's asking, is this available now? The standard is available at ohis.org. Yes, I was shocked to find a 4-letter .org domain that was still available. Nevertheless, one that I actually used. The OHIS acronym came before the domain name did, so I was excited about that. ohis.org is where all the information is there. That website is woefully under-informed and out of date, but it's still where everything is.
And then you have some products available as well, commercially.
Yeah.
Right?
Yeah, so OHIS is a standards advocacy thing, so ohis.org is where all of that is. If you want to buy the adapters that Halibut Electronics makes, that is at electronics.halibut.com.
Excellent. Thank you again so much, Mark, for being on. And for everyone else, I think Tobias is going to start live streaming in about 15 minutes. So if you're not subscribed to Tobias, there's a link down below to his channel. Make sure you click that and watch Tobias build things, which I've decided not to live stream anymore.
Mark, I would like to say too, this was a great stream, man. And I joke, but I mean it. I feel smarter as listening to you, man. You're awesome. Thank you.
Thank you very much. Thank you.
Thank you. And And good luck on Pacificon. And until next time, guys, 7-3. See you next Sunday. And we don't know what we're going to talk about yet, but we're going to get there. 7-3.
7-3, everybody.
7-3.
That was fun. Thanks.
Be good humans.